rational functions because we're generalizing our rational functions from A, H, and K form to basically cover anything. So the critical values that we're going to find are the x and y-intercepts, the vertical and horizontal asymptotes, and then eventually we're going to add a hole in the graph, which when we get there you'll see what that looks like. But for sure those first four for all of them, the two intercepts and the two asymptotes. And then again, still talking about domain and range and all the critical information. Alright, so you don't have to write this part down. I just wanted you to see the similarities between the three rational forms and our three quadratic forms that we did for quadratics and cubics, really. Standard form has no parentheses. Standard form had no parentheses. Transformation form has A, H, and K. Transformation form has A, H, and K. Obviously, it's not called vertex form because there's no vertex here. And then factor form has a bunch of parentheses. Right now, there's only two, but we're going to see some that have four sets of parentheses, two on the top, two on the bottom. And this part will kind of get as we go along. So I'm going to skip that part because we're going to learn each one of these. From last week, we saw the graph is the double L shape. Again, it's called a hyperbola. These are rational because we're dividing a polynomial divided by a polynomial. We are going to start off by dividing two linear expressions. So a y equals mx plus b over a y equals mx plus b. And then we're going to end today with a quadratic over a quadratic, which is the axb over ax squared plus bx plus c on the top and on the bottom. So we start off with the standard one, linear. Then we'll end up with the quadratic one, and that's not even the highest you can go. You can have a cubic divided by a quadratic. I don't think we're going to get that far. That's the part that I'm going to kind of skip over. So we'll for sure do linear, quadratic, but I think that's all we'll have time for. Again, the shape from last week is called a hyperbola, that double L shape. In A, H, and K form, the H gives you your vertical, the Y, the K gives you your horizontal, and the domain are all real numbers except the two asymptotes because that's what they can't be. The domain can't be the H because then you have a 0 on the bottom, and the range can't be the K because your fraction can't ever be that. Alright, again, nothing you have to write down right now because there's no space for you to write this down. Just reviewing everything from last week as far as graphing, because we're going to have the same graph today, but we're going to be looking at a different form. So we'll be able to get the asymptotes looking at something different, and we'll be able to get the intercepts looking at something different. Alright, so here's the form for today. It's still the hyperbola shape. Eventually, it's not going to be the hyperbola anymore. The double L. Right now, it's still a hyperbola because it's still linear over linear. As soon as I put a quadratic in there, completely different. Okay, they're not simple rationals anymore. They're more generalized, and they look different. Okay, they're not the same shape anymore. For all of these, we for sure need to get the intercepts and the asymptotes. So different combinations of the A, B, C, and D give you each one of these things. So again, it's important you know which one is which. Alright, so first, the vertical asymptotes. Remember, the vertical asymptote is what x cannot be. The thing that x cannot be is what makes the denominator 0. That's when the graph is undefined. So you set the denominator equal to 0, and you solve for x. In a linear equation, that's easy. Subtract the number on the outside, divide by the number on the front. As we get to quadratics, we got to do a little bit more. But for linear, that's it. Solve for x, just like you do any regular linear equation. So if you think about why they are what they are, it makes it a little easier to remember. Otherwise, you just have to memorize it. So vertical asymptote is when the denominator is 0, because we can't divide by 0. Undefined, and that's what it cannot be. Vertical asymptote is what the graph when the graph crosses the x-axis, which happens when y is 0. A fraction is 0 when the numerator is 0. So 0 divided by anything is 0. So to figure out the x-intercepts, I make the numerator equal to 0 and solve for x. So again, subtract b from the other side, divide by the a. This one has to be a coordinate. So the vertical asymptote is going to be an x equals equation. X equals whatever the number is. The x-intercept is going to be a point. So whatever that number is, 0, that's how you're going to have to type it in order for it to give you full credit, or in order to give you any credit. If you don't type in the x equals, or you don't type in the 0 for the y, it's going to come wrong. So you got to make sure you type it in correctly. Asymptotes are equations, intercepts are points. Alright, so that's vertical and that's x-intercepts. Notice these are both x's. So when you're looking for x stuff, you're looking at it horizontally, the numerator and denominator. For y stuff, you actually look at it vertically. So for the y-intercepts occur when x is 0. So if I plug in zeros for the x's, don't write this part down, but if I plug in zeros for the x's, if this is 0, 0 times a is 0, so this part goes away. If this is 0, 0 times c is 0, so this goes away. So those are the only two numbers that are left because they don't have x's with them. So I just divide those two. So the y-intercept, because it happens when x is 0, all I do is look at the constant numbers and divide. That's what ratio means. Ratio means you divide them into a fraction. So you just divide the last two numbers. Again, very similar to quadratics. Quadratics was the constant here. Same thing here. Now you just got to divide them. That's actually always going to be the case. And then the horizontal asymptote, there's really three possibilities. And you have to look at the exponents. So you have to look at the highest degrees. Right now, they're the same. There's just an x and an x on the bottom. So we can just look at the numbers in the front. So those are called the leading coefficients. The two numbers in front of x tell you the horizontal asymptote. Alright, so it's easy because the top gives you something, the bottom gives you something, the first numbers give you something, and the last numbers give you something. The hard part is knowing what that something is. Okay, each one gives you a different thing, so you have to know which is which. So this is kind of my summary poster, and I'll put this up eventually somewhere when I find my poster. The vertical, I circle the bottom, and I put VA. So that you know, set the denominator equal to 0, gives you the vertical asymptote. You don't have to write this stuff. That's just kind of summarizing everything we just did. This is the part you need to make sure you have labeled on your notes. Alright, and then the horizontal. Horizontal is the leading coefficient, so the numbers in front of x give you the horizontal asymptote, the HA. So HA. The x-intercept, again, occurs when the fraction 0, which is the numerator. The numbers on the top, set equal to 0, solve is the x-intercept. And the y-intercept are your constants, which are the last two numbers, and those give you the y. The constants give you the y. Remember, asymptotes are equations. You have to have the x equals and the y equals with the correct one. Vertical is an x equals line. Horizontal is a y equals line. Intercepts need to be points. So when you find the x and the y, that's the number that goes there, but make sure you put the other numbers as zeros when you type them in. Alright, so, okay, so you can can go back and look at those on how I got each one of them. But I'm going to work out example number 2 with you, kind of doing the same thing. Just knowing which is which, again, ahead of time, helps you memorize, well, which value, which equations give you each critical value. All right, so looking at example number 2. Vertical asymptote. Vertical asymptote is when the fraction undefined. The fraction is undefined when, I'm going to write it this time, the denominator is 0. So we're going to set the denominator equal to 0 and solve for x. Yes, there's some solving involved with this, but since it's not difficult solving, I'm not going to make you show work for it. I trust that a lot of these you can subtract and divide in your head. So here, we're going to add the 2 and get negative 1x equals 2. And then divided by negative 1. 2 divided by negative 1 is negative 2. Again, I'm showing the work here because these are your notes and I want you to know how we get them. But, I mean, sometimes it's just the opposite. You just move the number, that's it. I don't need to see work for all of these. A lot of them you're just dividing, so I really don't need to see work for those. Okay, the horizontal asymptote is you dividing the leading coefficients. So take the 2 numbers in front of x and divide them. So here we have a negative 2 and a negative, which the number would be a 1. So negative 2 divided by negative 1 is just positive 2. Do not type in negative 2 divided by negative 1.
Good afternoon.
Alright, and then going over to the intercept, the x-intercept is when the fraction is 0, the fraction is 0, and the numerator is 0. So numerator equal to 0, solve for x. So negative 2x plus 1 equals 0. Solve for x by subtracting 1. When I subtract 1, I get a negative 1 over here. And then divide by negative 2. Again, don't type these in as decimals. Negative 1 divided by negative 2 is just a half, positive half. Don't do 0.5s. I don't think it'll accept decimals. But remember, these are points. So 1/2 is the x coordinate. The y has to be 0. And then same thing for the y-intercepts. Y-intercept, there's only one. This is your constants divided by each other. So over here, y equals positive 1 divided by negative 2, which is just negative 1 over 2. Oops, I didn't leave enough room. Because I need to be 0 for the x and negative 1 over 2 for the y. Okay, leave them as fractions. Just make sure you reduce the fraction. If it's a negative, so notice here, the negative is with the denominator. If it's negative at all, just bring the negative to the whole front of the fraction. Don't type it in as 1 divided by negative 2. 1 divided by negative 2 is negative 1/2. Okay, if either one is negative, just make the negative go to the front of the fraction.